Welcome back to Introduction to iOS Application Development at SSFS. In the last video, we got our clock to work. It displayed the current time and it displayed it in a format that we could easily read and understand. We also posed the question at the end of what would happen if we shut down our phone or quit our iPad or move the app to the background. What would happen to the time at that point, or the time displayed? So in this video, we're going to take a closer look at that and get an idea of the concept of application lifecycle events. So the first thing we're going to do is we're going to run our app. So I'm going to hit the Command R, get it to run, and there's our clock, and it shows the correct time. We're just going to wait a second, and we notice that the time on the computer is 1:46, so it's showing the correct time. So we're going to go ahead and I'm going to hit Command Shift H. I'm going to send our app to the background. I'm going to bring it back. And notice that the time is 1:46. But I don't know if you can see it on the clock here, it's 1:47, and on the computer clock, it's 1:47. So it's not showing the correct time. Let's go ahead and quit the app this time. So Command Shift H twice. And I'm going to drag up to quit it. So now that app is quit. Let's go ahead and tap the clock again. But now it is showing the correct time. So it looks like it's only showing the correct time when the app first starts. So we need to fix that. I'm going to go ahead and stop. Well, it's already stopped. So the problem here lies with what are called event life cycles. And one life cycle event is view did load, and that's run whenever the view, which the label is part of, is loaded into memory. So we're going to actually put a print call in here. So let's do print view did load. Okay, so I've got a print statement in there. Let's go ahead and run that again so we can see when that's getting printed. And you'll notice that as it loads in, it shows the correct time, and I got the view did load. Let's go ahead and put that app in the background. So I'm going to hit Command Shift H to go home. Okay, again, it's just in the background. I just went home. Let's go ahead and press that again. Still shows the time, but notice that it did not print view did load. Let's put it in the background again. Let's wait for the time to change for a second. And now it shows the incorrect time. View did load. Let's go ahead and quit the app. Or open another app. Our friend Word Collage. And again, notice that view did not load. The view did load is not printed again. So it looks like this is only calling this once when the app first starts. So let's go ahead and quit. Let's see if we can quit the app. And it's not getting called. So let's go back to our main Xcode file. So we need to examine some of the other lifecycle events to find out when we can change our time so that it stays current and it shows the correct time. Well, notice that the class we're using right now is called ViewController, and it extends a UI ViewController. It's the same thing as being a subclass of UI ViewController. Since Swift is an object-oriented language, when I inherit from a class or I extend a class, I get all the methods of that class, and that's called inheritance. So my ViewController, since it extends UI ViewController, has access to all the methods and functionality that UI ViewController has. I just add some other specific things in here, like making a clock, adding labels to make my ViewController unique. So let's go ahead and open up the Xcode documentation, and let's look up UI ViewController. And this will give us all the information. I see there's some view methods here. There's view did load. Method is called after the ViewController has been loaded. If I scroll down, I see some other view events. I have view will appear, So when the view controller is about to be added, view did appear, view will disappear, and view did disappear. So some of these might be kind of promising. So let's try view will appear. So I'm going to go ahead and override that. So since view will appear is a function of or a method of UI view controller, if I want to implement my own functionality, I need to override it. So that's why I put the override function view will appear. And again, it fills that in for me. And my code, I'm going to actually, again, initialize the superclass, which is the UI view controller class. So view will appear. And I'm going to put in the animated parameter, which basically shows the animation of the view appearing. And then I'm going to copy this code, but instead of view did load, I'll put view will appear so that I can see, I can distinguish between the two lifecycle events. So let's go ahead and run this. Notice that I got view did load and view will appear. Both are triggered. Let's go ahead and try to, I'm going to do Shift Command H for home. So let's bring my clock back. Nope, view will appear didn't trigger again. Let's try going to another app and then coming back to the clock. Nope. And then let's go ahead and quit the app. And since the app is quit, it looks like view will appear is not the appropriate lifecycle message for us. The answer to which lifecycle event we want to use lies in a file that we haven't taken a look at yet. So over here in the Project Navigator, Command 1, the first file is called appdelegate.swift. You notice it's a class like almost every other iOS file. And you can see it extends UI responder, which means it's going to respond to certain events. And it implements this UI application delegate protocol. And all a delegate is, if you think of the word in everyday usage, when you delegate something, you are giving a task to someone that you either don't want to do yourself or don't know how to do yourself. So someone or something with a specialized set of skills will accomplish a task for you. Let's go ahead and take a quick look at the documentations, Shift Command 0, and we'll look at UI application delegate. Find it right there. And you can see it's a protocol, and it defines certain methods that we can use. So you can see here, there's a number of lifecycle events that the UI application delegate can handle. Finish launching, did finish launching, did become active, and so on. So there's a lot here that we can utilize in our application without having to write all that code ourselves. So let's go back. So instead of putting a print statement in each of our different lifecycle events, I'm going to go ahead and use something called a breakpoint. A breakpoint is something you insert into your code, and it tells the compiler to stop running and lets you see the state of all your variables and information so you can track down any problems. It's part of the debugging process. So I'm going to actually put a breakpoint here, and to do that I just click in the margin, and you can see this shape is a breakpoint. And if I right click or control click, I can edit it, and the action, I can log a message, and I could say view will appear. So instead of writing that print statement, I'll let the debugger put that in for me. Let's go ahead and run that. You can see it's on a clock. And you can see view will appear, but it stopped my program from running, and I can check the state of variables and objects that I have. You can see I've got a formatter, I've got an instance of a clock, and so on. I can hit the stop button. Let's go back. Let's go ahead and run it one more. Actually, let me go to edit my breakpoint. The one thing I forgot to do, I want to have it automatically continue so it doesn't stop. Sometimes it'll be helpful to stop, but in this case, I just want to see the message printed out. So let's go ahead and run it again. And you can see the view will appear message appeared, but I did not have to put the print statement. So again, we could do that with all the lifecycle events. Let me stop the clock and stop the clock. But if you look through app delegate, I think we'll find that application will enter foreground is probably the lifecycle event we want to detect. What we could do is we could write some code in here that gets an instance of the clock, but really our view controller in the MVC model, our view controller should be communicating with the view, not app delegate. So that's kind of a conflict of coding interests, as it were. So our view controller should have the code for what to do when the app enters the foreground. So what we need to do is we need to find some way to notify the view controller that our app has entered the foreground. And we'll look at that idea in the next video.